Good morning, students. Today in this class we are going to learn about a new chapter, that is alternating currents. In previous classes we have studied about the topics like moving charges magnetism, magnetism matter, electromagnetic induction. But in this class we are going to study about the alternating currents. So regarding the currents, we are having different types, like we are having the AC currents and DC currents. In previous chapters, that is in current electricity, we have studied about the DC sources and the circuit consisting of the DC sources. But here in this chapter, that is alternating currents, we will be discussing about the AC sources and the circuits consisting of the AC sources we are discussing here. So what is a DC current and what is an AC current? So both the currents will be useful for us. AC currents will be having some use for us, as well as the DC currents are also having the use for us. In some cases AC will be more advantageous compared with the DC cases, whereas in some other cases DC currents will be more applicable compared with the AC currents. Suppose if you want to charge a mobile, all of us are having the mobile phones and we want to charge the mobile phones, or you want to charge a secondary cells or rechargeable cells, secondary cells in the sense rechargeable cells. For the charging purpose, I can't use the AC source. For the charging of a particular device or a rechargeable cells or the secondary cells, or your mobile phones if you want to charge, then we require only the DC currents. By using AC currents, we cannot charge a mobile or a rechargeable cells. Is it clear? In similar way, if you see the house in our houses, as well as in offices, for most of the cases we will be using the AC currents. So the currents that we are using in our house for running a fan, for running a refrigerator, or for running many of the electrical appliances, we are requiring the AC currents. So in some cases we require the AC currents, and some other cases we will be requiring the DC currents. So both will be having some advantages over one another. Now coming to this chapter alternating currents, here we will be discussing only with the alternating type of currents. In the case of DC currents, which is a unidirectional currents, DC currents are also called as unidirectional currents. DC currents means they are the unidirectional currents. DC currents means unidirectional, that means they will have a single direction. That means these currents always moves from positive terminal of the cell to the negative terminal of the cell. Whatever the way you are connecting the cell in the circuit, always the current flows from positive terminal to the negative terminal. That means the direction is confined. It is having a single direction. The DC currents are also called as unidirectional currents. Unidirectional currents. Whereas AC currents are nothing but the bidirectional currents. So AC currents means what? These are the currents whose directions will be changing periodically. According to the mathematics, we know that sine and cosine functions are periodic functions. Even the linear combination of sine and cosine functions are also periodic, but general cases we will be considering means the sine function, cosine function will be periodic functions. Here in this alternating current chapter, we will be dealing with those sinusoidal functions, sinusoidally varying the voltages and sinusoidally varying the currents. So here these currents, AC currents are the bidirectional currents. Their direction of current will be changing alternatively or periodically. And these are also called as which currents? AC currents are called as bidirectional currents, because their direction of current is not fixed with time. They will be changing periodically, bidirectional currents. In most of the cases, that means in most of the DC current case, the magnitude of current is fixed. It does not changes with respect to time. When most of the DC current cases, the direction of current as well as its magnitude will be fixed. But in the case of AC currents, the direction of current will be changing with respect to the time periodically. Is it clear or not? So how it changes periodically with time, we are going to discuss. Not only the direction, even the magnitude of the current or the strength of the current is also going to be varied periodically in AC type of currents. And AC currents will be having more advantages compared with the DC currents, because in most of the cases, suppose in the electrical companies who are selling the electrical power, in such a cases for the transmission of electricity from one place to the another place, we'll be using the AC form, because the AC currents can be easily varied. That means their strength can be easily varied using the devices called transformers. So the magnitude of these AC currents can be varied with respect to the by using a device called the transformers. So we can have a conversion from high voltage low currents to low voltage high currents and vice versa. And these AC currents will be having some particular or peculiar characters, and those characters of these AC currents will be useful in some applications. For example, in our household things we will be seeing, we will be using the radios, we will be using the TVs. In the TV tuners or in radio tuners, we are suppose if you want to see a particular channel, we have to tune that channel. Simply nowadays we are using a remote for fixing a particular channel, yes or no? So in old, so for example, if you are having 93.5 radio Mirchi, if you want to listen, then you have to set a frequency equal to 93.5 FM. That megahertz frequency is to be set, yes or no? So what is happening in such a case? In such a case, the alternating current will be under resonance condition. At resonance, the power consumption will be the maximum and we can hear to that particular channel. And resonance is the characteristics of this AC currents which will be used for a particular purpose. Not only this, in many other characteristics of AC currents will be useful in different kinds of applications. One such application that we are studying in this chapter is about the resonance of LCR series circuit. So this LCR series circuit at resonance can be used for the tuning of instruments like the radio tuners or TV tuners or etc. So that is the advantage of these AC currents over the DC currents. And in houses we are using which type of currents? We are not using the DC current, but we are using the AC currents. So if that is the answer given by me, in our houses we are using the current for charging our mobile phones. I am telling the current that is coming in the house is AC, and I also told you that AC cannot be used for charging. Then how we are using AC current for charging your mobile phones? In such a case, we are using the adapters will be used. That means the charger, if you see in the charger there will be an adapter which is going to convert the AC into the DC currents. So we are having certain devices to convert the AC currents into DC currents also. So in that way, though the current in the house is a AC type, that can be converted into DC type for particular kind of applications. Is it clear or not? So this is a basic knowledge about the AC currents. Now in this chapter AC currents, what we are going to learn? We will be going to learn about the different kinds of circuits, like a pure resistive circuit, a pure capacitive circuit and a pure inductive circuit, and later we will be going to learn about the LCR series circuit at resonance. LCR series circuit we are going to learn at resonance, and then we will be learning about what is meant by resonance and what are the conditions for resonance we will be going to learn. At the end of the chapter we will be going to learn about the transformer. At the end of this alternating current chapter, we are going to learn about what? Transformer. So what are the basic things that we are going to learn in this alternating current chapter means? First we will discuss about the circuits. Which circuits we will be discussing means? First we will discuss about the pure resistive circuit. That means a resistor connected with a AC power supply. Later we will study about an inductor connected to an AC power supply, and then we will be learning about the capacitor connected to a power supply. Later we will be learning about the LCR series circuit, and in this LCR series circuit we will going to learn about how the current will be generated in this LCR series circuit, what is its strength, what is meant by the term called impedance, and then we will be studying the conditions for resonance, and what is resonance we will be studying. So first coming to this the first one, that is the resistive circuit, pure resistive circuit. What is a pure resistive circuit? In the pure resistive circuit, we will be taking a resistor, and that resistor is to be connected in series with an alternating kind of source. And alternating sources will be represented like this. Symbolically, alternating source is represented like this. This indicates a sinusoidal form of variation. Is it clear? This is an AC source, symbolically represented like this. To this AC source, we are going to connect a pure resistor having a resistance of R. We know that resistance is nothing but opposition to the flow of current is said to be the resistance. So if there is a resistor, that resistor will have some resistance. Let me take that resistance as R. And now this resistor is connected in series with whom? It is connected in series with an input AC kind of source. Input AC source is there whose voltage is given by V is equal to Vm sine omega t. So already in the previous chapter, that is electromagnetic induction, I told you about the AC generator. In an AC generator, we are going to generate an EMF which is varying sinusoidally according to the formula E is equal to Em sine omega t. This is a sinusoidally varying kind of EMF. So that EMF here I am taking it as the source is having an EMF or the voltage which is represented sinusoidally by the function Vm sine omega t. What is this Vm refers to here? Left hand side representing the voltage, right hand side term should also represent the voltage. But we know that this sine omega t is a mathematical function. It does not have any kind of physical meaning. It is having only the mathematical meaning. Sine omega t can have a value which is fluctuating between -1 and +1. In such a case, the value of V changes between minus Vm and plus Vm. If it is minus 1 into Vm is minus Vm. If it is plus 1, its value is plus Vm. Therefore, this alternating voltage V always fluctuates between the two values of minus Vm and plus Vm. Is it clear or not? So, this is a sinusoidally varying kind of voltage or alternating kind of source whose voltage is represented by V is equal to Vm sine omega t. What is this Vm refers to? This being the voltage, left hand side term being the voltage, right hand side term must be the voltage, and this sine omega t is a mathematical function which does not have any physical meaning. Therefore, this Vm is also representing the voltage, but this is the maximum voltage, hence V suffix m I am taking. So what is this Vm refers to means it is referring to the maximum voltage or the peak voltage or the amplitude of voltage. Is it clear? I can give the three names for this Vm. Vm refers to what? Vm refers to maximum voltage, or I can also call it as peak voltage, or I can also name it as amplitude of voltage. So we will have a idea that amplitude in the sense we may go with the wrong notion. That means in our first year part we have studied that amplitude means the maximum displacement is called as amplitude. But in all the cases, it is not the displacement. It is the physical quantity whose value is maximum is said to be the amplitude. For example, if I write V is equal to Vm sine omega t, V being the voltage, Vm being the amplitude of voltage or the maximum value of voltage. Is it clear? If I have written that there is a force periodically varying given by F is equal to F naught sine omega t, then this F naught is said to be the maximum amount of force or the peak value of force or the amplitude of force. Suppose if I have written I is equal to I naught cos omega t, otherwise sin omega t, whatever it might be. So I being the current, this I naught represent the maximum current or the peak current or the amplitude of current. So in this way, suppose if there is a velocity of a body which is varying periodically with time, then the velocity of the body which is varying periodically with time can be represented with V is equal to V naught sin omega t or cos omega t. In this V naught refers to what? V naught refers to the V being the velocity, V naught refers to the maximum velocity or the peak velocity or the amplitude of velocity. What here we need to understand means amplitude doesn't say that it is the maximum value of displacement always. So it is the maximum value of the given physical quantity. Is it clear or not? So if that physical quantity is velocity, it is the maximum value of velocity. If that physical quantity is force, then it is a maximum value of force. So for example, if there is a pressure variation which is varying periodically as P is equal to P naught sin omega t, then what is this P naught refers to now? P naught refers to the maximum pressure or peak value of pressure, or I can say amplitude of pressure. Is that clear? Now, first we will be discussing about what here? We will be discussing about the resistive circuit, pure resistive circuit. In this pure resistive circuit, we will study how the current and voltage are related with each other. Are they in phase? Are they not in phase? If they are in phase, how they are represented graphically and how they are represented using the Phasor diagrams. What is a phasor and phasor diagrams I will tell you later. First we will be discussing about the pure resistive circuit. First one is, in this alternating current chapter, the first question that we need to learn about is pure resistive circuit. Pure resistive circuit. In this pure resistive circuit, what we are considering? We are considering a resistor of resistance R which is connected in series with an alternating kind of voltage source whose voltage is varying according to the function V is equal to Vm sine omega t. That is what I am going to write here. Consider a resistor of resistance. Consider a resistor of resistance R. Connected in series with an alternating voltage source, voltage source whose voltage is changing periodically, with time. Let the AC voltage is represented by, let the AC input voltage is represented by V is equal to Vm sine omega t. Let me take it as equation number 1. Now, as it is a circuit, for this circuit I can use the Ohm's law or I can use the Kirchhoff law. Either you can use the Kirchhoff loop theorem or the Kirchhoff voltage law, or you can also use the Ohm's law. According to Ohm's law, if in this circuit at particular instant of time, if the current is I, then voltage drop across this resistor will be V is equal to IR according to Ohm's law. Therefore, voltage drop across this resistor is nothing but I into R according to Ohm's law. Or let me take the current in the circuit at some particular instant of time is I. So here I am not representing the direction for current. Why I am not representing the direction for current means the direction for current is varying periodically. At some instant it may be directed like this, at some other instant it is directed like this. So it is changing periodically. Therefore I can't know the direction for the current. At a particular instant only I am able to guess the direction for the current. So therefore let me choose the current in the circuit as I at some particular instant of time. Now let I be the current in the circuit, at some particular instant of time, at some particular instant. Now, according to Ohm's law, the voltage drop across the resistor is given by the voltage drop across resistor is given by the voltage drop across resistor V is equal to what? I into R. But the applied voltage is what here? V is equal to Vm sine omega t. But V is equal to Vm sine omega t. Therefore, using 1 into what I can say? Therefore, using equation 1 and equation 2, what I can say here? I into R is equal to Vm into sine omega t. Shall I write like this or not? V is equal to IR and V is equal to Vm sine omega t. Just equate the two terms. Then I will be having this. This can be written like this. I is equal to Vm divided by R into sine omega t. If you see this equation here, left hand side term represents the current, then right hand side term must and should represent the current. Sine omega t is a mathematical function, it does not have any physical meaning here. Therefore, Vm by R must and should represent what? It must and should represent the current, and that too, that is representing the maximum value of current. Therefore, I can write this as I is equal to Im sine omega t, where this Im is equal to Vm divided by R is the maximum current or the peak current or the amplitude of current, I can say. Is it clear or not? Now, let me take this equation is 1, sorry, this equation you take it as 2 and this as equation 3. Now here equation 2 and 3. Now see here. Now take this equation as equation number 4. Now just glance the equation 1 and equation 4. From equation 1 and 4 what we are understanding? By observing equation 1 and 4, it is clear that by observing equation 1 and equation 4, what I can say? V is equal to Vm sine omega t and I is equal to Im sine omega t. If you see these two equations, this is sine function sine omega t and this is also sine omega t. Is there any phase difference between the two? So here this is sine omega t and this is sine omega t. There won't be any kind of phase difference between this and this. Therefore, the phase difference between or the angular difference between the current and voltage in a pure resistive circuit is 0. Or else I can say that current and voltage are in phase. If there is no phase difference, I can say that they are in phase. So in a pure resistive circuit, what I can say, by observing equation 1 and equation 4, I can say current and voltage are in phase. Current and voltage are in phase. Or the phase difference between voltage and current will be 0. In which kind of circuit? In pure resistive circuit. In pure resistive circuit. Pure resistive circuit. Is it clear or not? Now, if they are in phase, then how to represent the current and voltage in an AC kind of circuit? In a pure AC resistive circuit, how this voltage and current will be varying sinusoidally, that we are going to represent graphically here. So let me take, this is the variation of voltage or current and this is the variation of time. So this is representing the time axis or the angle, and this is representing y axis is representing the current and voltage. Now we know that voltage is given by V is equal to Vm sin omega t, yes or no? And here Vm sin omega t is a periodic function, therefore the graph for voltage versus omega t is what? The graph for V versus omega t is a sine function. So if this is representing the omega t value, then the variation of voltage with time can be periodically represented in this way. This is how voltage is varying with respect to the time periodically, and this is representing what? This is going to represent the maximum voltage. This is V suffix m and this is voltage function Vm sin omega t, I can write. Is it clear? And now, how the current is changing? Current is also changing periodically with time only. Therefore, how to represent the current? And if you see the amplitude of current and amplitude of voltage, amplitude of current and amplitude of voltage, if you choose, generally R will be greater than 1. Therefore, this Im is always, this is greater than 1 means this Im is less than this Vm value. Therefore, in terms of amplitude, if you consider, the current amplitude is a little bit lesser than the voltage amplitude. Therefore, according to that, the graph will be plotted in this way. So, let me choose here. This is the variation of current with omega t. So if you observe this, this is representing what? This is representing the maximum value of current, and this is the function represented by Im sin omega t. Is it clear or not? So both voltage and current are 0 at the same time, and both of them are maximum at the same time. So if voltage is maximum, current is also maximum. If voltage is minimum, current is also minimum. That means they are always moving in phase. Therefore, the phase difference between voltage and current in a pure resistive circuit is 0. Is it clear? This is the variation or the graphical representation of voltage and current in a pure resistive circuit. And from that graph, we can say that voltage and current are in phase. In phase means what? Both of them will have the same, both of them will be maximum at the same time, and both of them will be minimum at the same time. If this Vm is 0, Im is also 0. V is maximum, I is also maximum. V is negative, I is also negative. So they are changing or they are in phase. Current and voltage are in phase. In which kind of circuit? In a pure resistive circuit. And we will be remain with the how much power is consumed in this circuit and what is the phasor representation for this voltage and current. Generally, current and voltage are dash kind of physical quantities. Current is a scalar physical quantity and voltage is also a scalar physical quantity. But here phasor diagram is the one which I am introducing, in which I am using a phasor as a vector. A phasor is nothing but a rotating kind of vector, and the projections of this rotating vector will be representing the scalar functions, and those are nothing but the current and voltage values. Is it clear or not? So current and voltage are in general they are scalars, but when for simplification or for problems simplifying, what we will be doing means we are taking them as phasors. If they are taken as phasors, phasor is nothing but a rotating kind of vector, and the projections of these rotating vectors will be representing the scalar functions called current and instantaneous current and instantaneous voltages, and that I will tell you once again afterwards. And as it is taken as a rotating vector, the phasor diagram for this voltage and current in a pure resistive circuit will be drawn like this. The phasor diagram. Phasor diagram. So, is voltage a scalar or a vector? Voltage is a scalar. Current is also a scalar. But here, for problem simplicity purpose, we are introducing a quantity called phasor quantity, which is a rotating kind of vector. I will tell you later. But let me take here the phasor diagram here. How to represent the phasor diagram means, here, let me choose, this is the voltage vector. This is the voltage vector, and from here to here it represents the maximum value of voltage. I will take it as Vm. I will take it as Vm. And now this vector is a rotating vector which is rotating in anti-clockwise sense with angular speed omega. The phasor diagrams, generally in the phasor diagram, the rotating vector will be taken to be rotated in the anti-clockwise sense. If the angular speed is omega, in a small interval of time it will rotate by an angle omega t. Is that clear? Now here current and voltage are in phase. Therefore, if voltage vector moves by an angle of omega t, then current vector should also move by the same angle. Therefore, this is the representation for current. This is the representation for current. If you see here, this from here to here, it is the amplitude of current Im. So, what is the projection of this Vm on the y-axis? This is Vm. This being, if I take it as theta, Vm cos theta this is, and this is Vm sin theta. Therefore, this is Vm sin theta means sin omega t. And here, what is the projection of this rotating vector on the y-axis? Im sin omega t. Is it clear? So, the projections of these vectors are represented the scalar functions. So, here Im sin omega t is a scalar and Vm sin omega t is a scalar. Is it clear? That is how we are using the phasor diagrams. So, this is the phasor diagram for voltage and current in a pure resistive circuit, which says that current and voltage are in phase. If voltage vector rotates or if the voltage phasor rotates by an angle 30 degrees, current phasor also rotates by an angle of 30 degrees in the same sense. Therefore, always they will be in phase. Is it clear? And next we will be learning about how much power is dissipated or how much power is consumed in this pure resistive circuit. So, calculation of AC power dissipated through the resistor that we are going to discuss now. Is it clear? So, here we will be discussing about how much power is dissipated when AC current is passing through a resistor is a question. So, from Ohm's law or in the current electricity topic we have studied that when a current of 5 amperes passes through a resistor for a time of t seconds, then the amount of power dissipated through it is given by I square R. Yes or no? So, when a current of 5 amperes is passing through a resistor for a time of through a resistor having resistance R for some amount of time, there will be some power dissipation. And the amount of power dissipation we calculated using the formula P is equal to I square R. Then, what is the power dissipated here? We know that PDC, DC power or the DC power that is dissipated is equal to I square into R. Yes or no? Or IDC I can take here, IDC into, where IDC refers to the DC current, IDC square into R. But here we are discussing about the power dissipated through the AC circuit. Therefore, in AC circuit, what I can say? The AC power dissipated is equal to IAC square into R. Yes or no? But what is the AC power here? AC power, just now we calculated that I is equal to Im into sine omega t. Therefore, this implies AC power that is dissipated is equal to Im into sine omega t whole square into R. Since the AC current I is equal to Im into sine omega t, which we derived just now. Now, using this, what I can say? AC power dissipated is equal to, this is AB whole square means A square into B square. Therefore, this is Im square into sine square omega t into R. Yes or no? So, here what is this is the instantaneous AC power that is dissipated. But I want the AC power dissipated over the full cycle, over the full AC cycle. Then what is the average power dissipated? Average AC power dissipated, AC power dissipated is equal to, is given by. So, here I am using the notation like this. This notation represents average. So, something which is kept in this bracket term will represent the average of the term. Suppose if I write like this is the average value of x. If I write some z, average value of z. If I write some p, average value of p. If p is power, then it represents the average power. And in some other cases, we can also represent the average values like this, p bar. P bar also represents the average value. Like this also you can represent the average value. Now here I am going to calculate the average power that is dissipated over a full cycle. Therefore, the average value I am writing like this. Average value of AC power is equal to, for this I can write it like this. What is PAC? Nothing but Im square into sine square omega t into R average value. So we know that Im is a maximum value which is constant, and R is the resistance value. For a given resistor, its value is fixed. Therefore, here Im is a constant and R is a constant, so you can write them outside. The average of constant terms does not changes. Now, I can write it as average AC power is equal to Im square into R into average value of sine square omega t. But what is the value of average value of sine square? Mathematically, we can show that average value of sine square theta over a full cycle is always equal to half. What is the average value of the sine square theta value? Half. Whereas, average value of sine theta over a full cycle, it is always equal to 0. Mathematically we can show that the average value of sine theta over full cycle is 0 and average value of sine square theta over full cycle will be half. I will tell you later, but now here I am directly taking the average value of sine square term. Here in the place of theta omega t is there, so theta can take any value, it is none of our business here. Therefore, I can take sine square omega t average value over the full cycle value directly as half. Therefore, I can write it as AC power over a full cycle is equal to Im square into R into average value of sine square omega t is half. This implies AC average value over full cycle is equal to half into Im square into R. Shall I write like this? AC power average value over full cycle is equal to Im divided by root 2 whole square into R or not? Yes or no? I will write this Im by root 2 whole square as PAC average value is equal to IRMS square into R, where IRMS is equal to I maximum by root 2. So this is a very important term that you have to remember for all kind of examination. So what is this IRMS refers to? IRMS refers to root mean square current, RMS current, which is also be called as virtual current or equivalent current or effective current. The effective current or the equivalent current or the virtual current can be called as the RMS current. Why it is called the equivalent or the effective current? It is just like the case if three resistors are having resistances R1, R2, R3 are connected in series. The effective resistance is given by what? Rs is equal to R1 plus R2 plus R3. That means what it says. Suppose there are three resistors having resistance 1 ohm, 2 ohm and 3 ohm and they are connected in series. Then what is the effective resistance of them? 1 plus 2 plus 3, that is equal to 6 ohm. Yes or no? What is this 6 ohm refers to? It is the equivalent of those 1, 2 and 3 ohms. That means I can replace all the three resistors with a given resistor so that the effect does not changes. Yes or no? The effective value or the equivalent value or the virtual value means it is a value which can replace the previous value so that the effect does not be changing. So here RMS current is what? How we are going to define this RMS current? If you see this formula, AC power average value is equal to IRMS square into R. This term and this term you just compare. They are looking the same. Here this is the average, this is the DC power average value and this is the AC power average value. And right hand side term if you see, here R is same in both the cases, IDC square and IRMS square is there. So what is this RMS current? RMS current is that DC current. It is nothing but which current? It is that DC current which will produce the same heat that is produced by the RMS current is that DC current which will produce the same heat that is produced by the alternating type of current while passing through the same resistor. Is it clear? So what is RMS current definition? RMS current is that DC current which when passes through the same resistor will give the same amount of heat while passing through the alternating type of current. And RMS current is equal to how much? Im divided by root 2. So the root mean square current, this is just like the root mean square speed in the gaseous systems. That means in the kinetic theory of gases we have studied about the RMS speed of gas molecules. In the similar way this RMS current is also be evaluated. So if you see the current, the instantaneous current, that is IAC is equal to Im into sine omega t. What is its average value over the full cycle? Average value of this is nothing but average value of sine omega t. Average value of sine omega t over full cycle will be 0. Over a full cycle, AC current value will be becoming equal to 0. But the power dissipated is not equal to 0. Though the AC power average, AC current average value will be 0 over a full cycle, that doesn't mean that the power dissipated over a full cycle is equal to 0. We are having some power dissipation. Why? Because here in the place of here what we are having I square term is there but not the I term. I square term says that whether the current is positive value or the negative value, for both of them I square term will be positive. Therefore, there will be some power dissipation even though the average current over the full cycle is equal to 0. So we need to define a current called here, a special type of current called RMS current here. And what is the definition for RMS current? RMS current is, if by comparing these two equations I can say that RMS current is that DC current which when passing through the same resistor will produce the same heat as that produced by the AC current passing through it, and its value is given by IRMS is equal to Im divided by root 2. The peak current by root 2 is giving the value of RMS current. And what is this 1 by root 2 value? 1 by root 2 is nothing but I can write it as 0.707. Why? Because multiply with root 2 and divide with root 2, then I can write it as IRMS is equal to root 2 divided by 2 into Im, multiply with root 2 and divide with root 2. Then root 2 divided by root 2 into root 2 is 2. Root 2 value is 1.414. 1.414 by 2 is 0.707. This implies IRMS is equal to what? IRMS is equal to 0.707 times Im, or else 70.7% of maximum current is RMS current. What is RMS current? 70.7% of maximum current or the peak current is the RMS current. And these will be used for the competitive part of examinations. For CE2 to board standard exams or NEET examinations, this formula will be useful. So IRMS is equal to what? Im divided by root 2, and RMS current value is equal to how much? 70.7% of maximum current. Is it clear or not? So if I want to draw the graph pictorially for this, if this is the AC current, if this is the AC current and this is said to be the maximum value of AC current, that is Im, then IRMS is equal to how much? IRMS value is like this. This is IRMS, and this IRMS is equal to 70.7% of Im. Is it clear or not? So this is about the variation RMS current and the peak current relation. Is it clear? So now, so what is RMS current? RMS current is that DC current which when passes through the same resistor will give the same heat as that produced by the AC current. And IRMS is equal to I maximum by root 2, and IRMS is equal to 70.7% of the maximum value of the current. And one important thing that we need to notice here is, though the average value of current in a full cycle is equal to 0, the average power in a full cycle is not equal to 0. There will be some power consumption. Why? Because there is in the power term there will be I square term. I square term is there, therefore whether the current is positive or negative, always will be having the positive value, because I square is always positive. That is about the AC power dissipated through the resistor. Is it clear or not? So this is about the power dissipated through a resistor in an AC circuit. See, I told you that average value of sine theta over full cycle is 0 and average value of sine square theta over full cycle is half. I'll tell you how they will be going to be 0 and half mathematically. See here, average value of sine theta, I have taken it to be 0, and average value, this bracket term says that it is average. Average value of sine square theta is equal to half. Not only sine, even with cos also. Average value of cos theta over full cycle is equal to 0, and average value of cos square theta over full cycle is equal to 0. So in the competitive kind of examination, we should not go with the derivation part of this average value calculations. Directly we can take them, granted. So square terms there means their average value over full cycles. I am not discussing over the half cycles, over the full cycles only I am discussing. Over the full cycles, their average value sine square and cos square values will be equal to half, whereas the average value for sine and cos over the full cycle will be equal to 0. Now I will go with the sine terms and you have to carry out with the cos term. Now I will tell you about the sine term average value calculation. So what is this sine theta average value means? It is nothing but I have to calculate this over the complete term I need to calculate. Therefore I can take it like this. So what is this means? Average value of integral of sine theta d theta divided by integral d theta. It is a mathematical way of representing the average value. So where the theta value changes from where to where. In a full cycle theta varies from 0 to 2 pi. If this is a complete circle, so here if we start 0 angle and over complete circle it is 2 pi. So 0 theta value varies from 0 to 2 pi. So here also 0 to 2 pi. Now what is this value? We know that integral of sine theta is nothing but minus cos theta. Therefore I can read it as minus cos theta, where the limits varying from 0 to 2 pi divided by integral d theta is nothing but theta. Integral d theta is theta, where the limits changing from 0 to 2 pi. So that is equal to, first in the place of theta I have to substitute the upper limit, then minus of, in the place of theta I have to substitute the lower limit. Therefore according to that, cos of minus cos of 2 pi minus cos of 0 divided by theta means first I have to substitute 2 pi minus lower limit for theta is 0. So what is its value? Cos 2 pi is nothing but cos 360. Cos 360 value is how much? 1. Here minus is there, therefore minus 1. Minus of minus is plus. Cos of 0 is how much? Cos 0 is plus 1 divided by 2 pi. So what you are getting? Minus 1 plus 1 value will be equal to 0. 0 by something is nothing but 0. This is how I can say that average value of sine theta over the full cycle is equal to 0. Here theta can take any value. Theta is the argument, and in that argument I can take omega t or whatever else. So we will be getting the same answer over the full cycles. Is it clear? Now in the similar way you can carry out with cos theta also. I will be going with the calculation of average value of sine square theta over the full cycle. What is the average value of this? This is nothing but integral of sine square theta d theta divided by integral of d theta. Is it clear or not? Now what is this average value? So theta is varying from 0 to 2 pi over a full cycle, 0 to 2 pi. Now how to write this sine square theta in terms of cos? We are having cos 2 theta is equal to 1 minus 2 sine square theta. Yes or no? From this one, what is this 2 sine square theta? Bring this to this side. Then 1 minus cos 2 theta is equal to 2 sine square theta, or sine square theta can be written as 1 minus cos 2 theta divided by 2. Now substitute this value for sine square theta in this equation. Then what you are going to get? Integral 1 minus cos 2 theta divided by 2 into d theta, where the limits varies from 0 to 2 pi, and integral d theta is nothing but theta, limits varying from 0 to 2 pi. Is it clear? This is. Now you can split the integration for the two terms. Therefore I can write it as integral 0 to 2 pi of half d theta minus of half into integral 0 to 2 pi cos 2 theta into d theta, all divided by, this is 2 pi minus, first theta means 2 pi I have to substitute, minus lower limit, that is 0. Is it clear or not? 0 degrees. This is equal to how much? So here half I can write outside, integral 0 to 2 pi d theta minus, you see here, this is nothing but, this is just like this case. So if you take this one, integral 0 to 2 pi cos 2 theta d theta is nothing but how much? 0 value. Therefore I am directly substituting here half into, so I can multiply with 2 and divide with 2, then here 2 divided by 2. So this is 1 by 4 into this overall integral value will be 0 divided by then 2 pi. So what is its value? Finally I will be getting sine square average value is equal to, so this term becomes 0 and this is half is there. Integral 0 to 2 pi d theta is nothing but, integral 0 to 2 pi d theta is nothing but how much? This is nothing but 2 pi. Therefore this is 2 pi and this is 2 pi. So half into 2 pi divided by 2 pi. 2 pi are going to be cancelling each other with each other. Therefore sine square theta is equal to, average value is equal to half. So finally what I can say is average value of sine square theta over full cycle is equal to 0 and average value of cos square theta over full cycle is equal to 0. In the similar way, average value of sine theta and average value of cos theta over the full cycle will be equal to 0. In the place of theta, we may be having omega t terms in this chapter. Is it clear? So every time no need to carry out these integration methods, directly we can go with these terms. Is it clear? But these are applicable only over the full cycles, not for half cycles. Is it clear? Okay, look here. So we have calculated the RMS current value and we got the value as IRMS is equal to I naught divided by root 2 or I maximum value divided by root 2. Yes or no? In the similar way, if this is true with currents, then with voltages I can write as VRMS is equal to RMS voltage is equal to Vm divided by root 2, where Vm refers to the maximum voltage. So IRMS is equal to Im by root 2 and VRMS is equal to Vm by root 2. Now we are going to calculate one more current term, that is the average current. Then what is average current? Over a full cycle its value is equal to 0. But in some cases we require to calculate the average current over a half cycle. Then what is the average current over a half cycle? As this is the representation for the current graphically, AC current graphically. So this is nothing but the maximum value of current, that is equal to Im, and this is the instantaneous current I is equal to Im sine omega t. So over a full cycle from here to here, this is 0, this is pi by 2, this is pi, this is 3 pi by 2 and this is 2 pi. Over this full cycle from here to here, its complete value will be equal to 0, because for every positive term here there exists a negative term here, and when you add them we are going to get the 0 value over the full cycles. But over a half cycle, is the current equal to 0? Over the half cycle all these values are positive only, so therefore they never add up to 0. So if they are asking you to calculate the average value of current or the mean current in an AC circuit, generally the mean current or average current will be calculated over the half cycle unless otherwise specified. The average current will be calculated over the half cycle only. If they specifically asked you to find the value of average current over the full cycle, blindly we can put the answer as 0. Over full cycle, average current as well as the average voltage will be 0. But generally calculating, we will calculate the average values over the half cycles. Now, what is the average current? I average or I mean? I mean or I average is calculated over how much cycle? Half cycle only. Then according to the definition, this can be written as integral I into d theta divided by integral d theta. Shall I write like this or not? But what is this? This is I is nothing but the I is nothing but Im into sine omega t into d theta. Or this d theta is nothing but, here theta is nothing but what? This is Im into sine theta. Okay, therefore I will take it as theta only. Therefore Im into sine theta into d theta, where this theta varies from where to where? Theta varies from 0 to 2 pi divided by integral, over half cycle we are calculating, therefore 0 to pi only I need to integrate. Therefore this is 0 to pi d theta. So what is its value? Im being constant, peak value being constant, I can write it outside of integration. Im into integral 0 to pi sine theta into d theta divided by, this is integral d theta is theta, limits varying from 0 to pi. Now what is its value? So I average or I mean is equal to Im into sine integration is nothing but minus cos, therefore minus cos theta, where the limits varies from 0 to pi. 0 to pi limits are varying. So this is theta means pi minus theta means 0. So I can write it as pi minus 0. So this implies I average is equal to Im into minus cos of theta means upper limit I have to substitute, that is pi, minus cos of, so minus of minus will be there, minus cos 0 degrees divided by pi. So what is its value? So I average or I mean is equal to how much? Im into minus cos 180 value is minus 1. So minus of minus 1 is minus of minus 1 is plus 1 minus, here minus is there, minus of minus again it is plus. Cos 0 is how much? Plus 1. Therefore this is whole divided by pi. Is it clear or not? So what is this value? This implies I average is equal to minus of minus is how much? Plus. Plus 1 is 2. Therefore this is 2 divided by pi, 2 by pi into Im. So this is one more important term that is used for the board 2-mark problems to the competitive level of examination. For board exams and for CET, NEET, all kind of examinations this is useful. So finally, what is the average current formula? I average is equal to 2 by pi into Im. What is this 2 by pi value? 2 by pi is nothing but pi is equal to how much? Pi is 22 by 7 I can say. Therefore, this can be written as I average is equal to 2 by 22 by 7 into Im. So 2 goes here 11 times, 7 by 11. This 7 goes up, 7 by 11 into Im. This is equal to how much? This is 0.663 we will be getting. So 0.63 into Im, which I can write it as 63% of Im. So average current value is equal to how much? 63% of the maximum current is nothing but the average current over the half cycle. In the similar way, average voltage can be written as V average is equal to 2 by pi. Similarly, average voltage is equal to what I can write? 2 by pi into Vm, where Vm refers to the maximum voltage. So IRMS is equal to what? Im by root 2. VRMS is equal to Vm by root 2. In the similar way, I average is equal to 2 by pi into Im, or VRMS is equal to 2 by pi into Vm here, and here I average is equal to 2 by pi into Im. Is it clear? So this is about the average value of current and average value of voltage. Average voltage is equal to how much percentage of the peak voltage? It is equal to 63% of the peak voltage. This is how we are calculating the average current. This derivation is not required, but the end terms will be useful for us for all kinds of examination. So we need to remember which formulas? RMS current formula, average current formula, RMS voltage formula, as well as the average voltage and RMS voltage formulas we need to remember. Is it clear or not? Finally, I am writing all those terms here. So Im refers to peak current or maximum current. Peak or maximum current. Second thing, IRMS is equal to Im by root 2, which is equal to 70.7% of Im. Similarly, Vm is nothing but peak voltage. This is peak voltage. And Vrms is equal to, this is Vm by root 2, which is equal to 70.7% of Vm. And I average over the half cycle is equal to 2 by pi times I maximum, which is equal to 67% of Im, or V average is equal to, over the half cycle is equal to 2 by pi times Vm, that is equal to 67% of Vm. All these terms will be useful for our competitive part of exam as well as for the board 2-mark level questions. Is it clear? This is about the average values and the RMS values. Next we will be learning about the pure inductive circuit, and then we will learn about the pure capacitive circuit. Okay. Next is about the pure inductive circuit. So in this pure inductive circuit, we will consider an inductor of ideal form. An ideal inductor is one which does not have any kind of resistance. Generally inductors are made up of what? They are also made up of copper wires, and each copper wire is having some resistance, yes or no? But a pure inductor or an ideal inductor is one whose resistance is taken to be 0. So pure inductor means it is an inductor with the resistance value 0. But an inductor will have an inductance that we have studied in the electromagnetic induction chapter. We have calculated the self-inductance of a coil, yes or no? So if there is a resistor, there is a for a resistor there will be a resistance. In the similar way, if there is an inductor, then it will have some inductance value. So consider an inductor, pure inductor of inductance L, and it is connected to an AC input source. So what we are choosing here, we are choosing an inductor. An inductor is symbolically represented like this, and it is connected across an input AC source. The pure inductor of inductance L is connected across an input AC source. AC source is symbolically represented like this, whose voltage is given by V is equal to Vm sine omega t. Now in this pure inductive circuit, we have to find how the current and voltage are related, or what is the phase relationship between voltage and current. That is what we are going to study here. So what we consider, that I am writing here. Consider an inductor of inductance L. Consider a pure inductor or an ideal inductor. A pure inductor of inductance L, which is connected across an input AC source, as shown. So the applied voltage here is mathematically represented by the applied AC voltage. The applied AC voltage is given by mathematically by Vm is equal to V is equal to Vm sine omega t. Take it as equation number 1. Let I be the current in the inductor at particular instant of time, or I is the arbitrary current in the inductor at particular instant of time. Let I be the current in the inductor, at some instant. That means at a particular time, the current in the circuit, we are choosing it as how much? I. At some instant. Is it clear? Now using the KVL or Kirchhoff voltage law, what I can say? Using KVL for the circuit, for the loop, what I can say? V minus L into di by dt is equal to 0. So where V is applied voltage and minus L into di by dt is the voltage drop across the inductor. From Faraday's law of induction, we have studied that across the inductor, the induced EMF E is equal to minus L into di by dt we have taken. Yes or no? So the applied voltage is V, and across the inductor the voltage drop is minus L into di by dt. For the full cycle, its value must be equal to 0. So from this, what I can say? V is equal to L into di by dt I can write. Yes or no? So from this, L into di by dt is equal to, write this term to this side, then is equal to V. But what is that V? From equation 1, V is equal to Vm sine omega t. Therefore I can write it as L into di by dt is equal to Vm sine omega t, using equation number 1. Is it clear or not? Now, what is my objective here? I know the voltage, AC voltage, but I want the current, AC current in the inductor. So I have to get the value of current, that is I want to get the value of I. So I is there in the differentiation term. In order to get the value of I need to integrate it. or I have to eliminate the differentiation, that means I need to integrate this term. So for that, further if I simplify this, I can write it like this. di is equal to what? Vm divided by L into, bring this d2 to this side, sin omega t into dt. Shall I write like this or not? Now, this implies integral of di is equal to, here Vm is a peak value which is constant and L is the coefficient of self-induction of the inductor or inductance of the inductor, which is also constant for a given inductor. So Vm by L term is constant, so therefore I will write it outside of integration. Then I can write integral of sin omega t into dt. Shall I write like this or not? Now what is this integration of this? Integral di is nothing but I. I is equal to Vm divided by L into, what is integration of sin theta? Cos theta, minus cos theta, sorry. Sin integral of sin theta is minus cos theta. So here omega t is there, but here t is there. Therefore multiply with omega and divide with omega. Then I can write it as integral of sin omega t divided by omega into d omega t. Shall I write like this or not? Write this omega outside. Then I is equal to, this implies I is equal to, omega is also constant, write it outside. Then Vm by omega L into integral sin omega t into d omega t. So if you take this as theta term, this is also theta. Integral sin theta d theta is minus cos theta. Therefore I can write it as Vm by omega L into minus cos omega t, since integral of sin theta d theta is equal to minus cos theta. Along with this, you will be also having the integration constant plus c. Integration constant plus c will be there. The value of c is obtained by applying the limits. That means taking the extreme conditions, we can get the value of integration constant c. But we know that at t is equal to 0, the current in the circuit is equal to 0. So if you take that into consideration and apply using the extreme conditions, the value of c is noticed to be 0. Therefore finally I can write it as, this implies I is equal to, so Vm into Vm by omega L into, this is minus of sin omega t is nothing but, I can write it as, sorry, cos omega t can be written as sin of pi by 2 minus omega t. Shall I write like this or not? Since sin 90 minus theta is equal to cos theta. Now this is I is equal to Vm divided by omega L into sin of minus theta is nothing but minus sin theta. Sin of minus theta is nothing but minus sin theta. So minus, you take it inside, then I can write it as sin of minus pi by 2 plus omega t. Therefore I can write it as omega t minus pi by 2. Shall I write like this or not? Because minus of sin theta is nothing but sin of minus theta. So you can send the minus sign inside in sin term. Then you will be having this. So I can write it as Vm divided by chi L. This is chi L into sin omega t minus pi by 2. What is this chi L? Where chi L is equal to omega L. And this is a very important term that we have to remember here. Chi L is equal to omega L represent what? If you see here, this term is nothing but current. Left hand side term is current. Sine function does not have any physical meaning. Therefore, this entire term should represent current. Vm by chi L should represent the maximum current. If this represents the maximum current, Vm being the voltage, then this must represent the resistance term. But the resistance in this inductor is called as inductive reactance. Just like a resistor will oppose the current in the circuit, an inductor will also oppose the AC current in the circuit. The opposition to the AC current in the inductor is called inductive reactance. What is inductive reactance? The opposition to the AC current in the inductor. The opposition to the AC current in the inductor is called as inductive reactance. And the unit for this inductive reactance is same as that of resistance, that is ohm. What is the SI unit of inductive reactance? Ohm. And same dimensional formula will be there as that of resistance for chi L. And this inductive reactance, if you observe carefully, this inductive reactance is directly proportional to omega, and it is also directly proportional to the inductance. More the inductance, more the inductive reactance. Less the inductance, less the inductive reactance. And omega is angular frequency, which can be written as 2 pi into f. Therefore, you can write it here as chi L is equal to 2 pi f into L. So this implies chi L is proportional to f. So higher the frequency of the circuit, higher will be the reactance value. Less will be the frequency, less will be the reactance. That means it will not allow the high frequency current. So an inductive circuit does not allow which frequency current? High frequency currents are not allowed, only low frequency currents are allowed. An inductor will oppose high frequency currents and allow the low frequency currents. Hence it is called as low pass filter. In the low pass filter cases, we can use the inductors. Inductors will allow the low frequency currents and blocks the high frequency currents, because more and more the frequency of the AC, more will be the inductive reactance, more the inductive reactance, current will be reducing. When F tends to infinity, chi L also tends to infinity, therefore current in the circuit goes to be 0. This can be rewritten in this way. I is equal to I maximum into sine of omega t minus pi by 2. Take it as, this is equation 1 we have taken, now take this as equation number 2. Comparing equation 1 and 2, what we are understanding. See this equation 1, this is Vm sin omega t, and see this equation 2, I is equal to Im sin omega t minus pi by 2. If you see this argument of sine function, here the argument is omega t minus pi by 2, here it is omega t. Out of omega t and omega t minus pi by 2, which is large? Omega t is large. How much large it is? Compared with this sine term, this is how much time large? Pi by 2 term, pi by 2, its value is more. Omega t is how much more than omega t minus pi by 2 means? Pi by 2 times it is more. Therefore, this function is leading this function. That means voltage is leading current by how much? By a phase of pi by 2 or 90 degrees. From equation 1 and 2, I can say that from equation 1 and equation 2, I can say current voltage is leading. Voltage leads current by pi by 2 or 90 degrees. Is it clear or not? This is very, very important theoretical question that they will be asking in the board examination. In a pure inductive circuit, voltage leads current by how much phase? 90 degrees. Answer is 90 degrees. Voltage is leading means current is lagging. One is behind means the other is at the back. Yes or no? So voltage leads current by 90 means current lags voltage by 90 degrees. So how I can say that voltage leads means, if you see here, omega t is larger than omega t minus pi by 2. This is refers to voltage and this is referring to current. So this is larger than this by how much? By 90 degrees it is large. Therefore voltage is leading the current by 90 degrees in a pure inductive kind of circuit. Understood this point clearly? So in a pure inductive circuit, voltage leads current by how much? 90 degrees. Next is how to draw the graphical representation for voltage and current in the pure inductive circuit, and the Phasor diagrams we have to learn. Along with that, we should also learn the power dissipated in this inductive circuit. Is that clear? Okay. Next is about the graphical representation of voltage and current in a pure inductive circuit. Graphically, how we are going to represent the current and voltage in a pure inductive circuit. Graphical representation of current and voltage in pure inductive circuit. Pure inductive circuit. So here we know that Vm is equal to what? V is equal to Vm sin omega t. And we know that current I is equal to Im sin omega t minus pi by 2. So that means, or else I can also write it as minus of Im into cos omega t I can write. Minus Im into cos omega t. So if you see these two equations, this is a periodic function and even this is also a periodic function. But this voltage is leading the current by how much? 90 degrees. Therefore, the representation, if you see the graphical representation for both of them, if you see, first I will draw the graph for voltage variation with respect to omega t. Voltage variation with respect to omega t is V is equal to Vm sin omega t. Therefore, it is a sinusoidal graph. It is a sinusoidal graph, and that sinusoidal graph can be drawn like this. This is the sinusoidal graph representing the variation of voltage. This is Vm sin omega t. This is omega t variation. So, and this is the peak value of voltage which is taken as Vm. Now, what about the current? Current is lagging or voltage is leading by how much? 90 degrees. That means when this is 0, this must be maximum, and this is maximum, the current should be minimum. But it is lagging by how much we are telling? 90 degrees. Therefore, the graph will be like this. The graph will be like this. So here, when this is 0, this is maximum but in negative value. This is maximum, this is 0. This is 0, this is maximum positive value. And again, this is 0 means this is what it should have. This should have the maximum value. And again, is it clear or not? So here 0, it is negative maximum, maximum 0, 0 positive maximum should be there, and negative means you should have the 0 value here like this. And again, this is 0, negative maximum should be there. So like this it is varying. Understood this clearly? So first voltage is moving and then current is following it. So this current variation, this is the peak value of current. I can take it as Im, and this is current graph Im sin omega t minus pi by 2. This is how current and voltage are varying periodically in this way. Now, what is the phasor diagram for voltage and current in this case? So, if I take the phasor diagram, what is a phasor? Phasor is nothing but the vector, rotating vector is said to be a phasor. Rotating vector can be used for representing the scalars. In scalars, the rotating vector y component represents the scalar function, and that is nothing but the scalar quantity that we are having. As I told you previously, what is a phasor means? A phasor is nothing but a rotating kind of vector used for representing the scalar physical quantities so that the problems can be solved easily. So, any simple harmonic kind of motion, if you are noticing, those simple kind of harmonic motions can be added algebraically using the phasor diagrams by taking them to be vectors, but they are actually not the vectors, but they are chosen to be vectors so that the problem can be solved easily. A phasor is nothing but a rotating vector. So here, if I use the voltage as a phasor diagram and a current as a phasor diagram, then here the voltage phasor is leading the current phasor by how much? 90 degrees. Therefore, the phasor diagram, if you see here, phasor diagram in pure inductive circuit, phasor diagram in pure inductive circuit. This is how we are going to represent the phasor diagram. So here voltage is leading. So if this is the voltage axis and this is its peak value, from here to here it is Vm, amplitude of voltage. Current is lagging by 90 degrees, it is lagging. This is current and its amplitude is Im, and voltage is leading current by how much? It is leading current by how much angle? 90 degrees. So this is equal to 90 degrees, or this is omega t. This goes like this with angular speed omega. This is also following it. Current also follows voltage by the same angular speed omega. This is the phasor diagram for the pure inductive type of circuit. Now what is the power in this power dissipated in this pure inductive circuit? Power dissipated calculation. Power dissipated I want to find out. In this power dissipated case, PAC is equal to VAC into IAC. Shall I write like this or not? Since power is equal to VI, that is what we studied in the current electricity term after Joule heating effect. So from this one, what is this AC power? AC power is equal to VAC is nothing but Vm into sine omega t. Here we have taken. And what is IAC? IAC is nothing but Im into sine omega t minus pi by 2. Shall I take like this or not? So this can be written like this. Average value of AC power is equal to, this is Vm into Im. They are constants, so write them outside, into average value of sine omega t into sine omega t minus pi by 2. So multiply this with half and divide with half. Then what you are getting? Vm into Im divided by 2 into 2 sine omega t sine omega t minus pi by 2. See here. This is 2 sine A sine B. 2 sine A sine B is nothing but cos of A plus B minus cos of A minus B. Then what I can write? This is Vm by root 2 into Im by root 2, because 2 can be written as root 2 into root 2. Now this is average value of, this can be written as what? Cos of A plus B. A plus B is 2 omega t minus pi by 2 minus cos A minus B. Cos A minus B is nothing but this minus this, that is nothing but omega t minus of omega t minus pi by 2, that is plus pi by 2. Cos 90 is how much? 0. And the average value of cos function, I already discussed that average value of this cos or cos term or sine term is 0. Therefore this is Vm by root 2 into Im by root 2 into 0 minus 0. So this is nothing but how much? This is equal to 0. So what is the AC power dissipated in a pure inductive circuit? In a pure inductive circuit, there is no dissipation of power, but there is an opposition to the AC current. In the case of resistor, there is an opposition to the AC current as well as there is some power dissipation. But in the case of inductive circuit, there is an opposition to the AC current, but there is no power dissipation. That is how, if you see this tube light is having the choke coil. Choke coil works on the principle of self-induction. Why we are using choke coil instead of a resistor in this tube light case? In the case of a tube light, why we are using this choke means, choke will oppose the current, but it does not dissipate the power. That's why we are not using the resistor. If I use the resistor in the place of choke coil, what happens? There will be opposition to the current. Along with that, there is some power dissipation. So instead of that, if I use a choke, there is an opposition to the current, but there is no power dissipation. That's why we are using the choke coils for the tube lights. Is it clear or not? So what is the importance of this inductor means? An inductor will oppose the current, but it does not dissipate the power. So there is no power loss in the case of pure inductive kind of circuit. This is about the pure inductive circuit. In a pure inductive circuit, voltage leads current by 90 degrees. Or current lags voltage by 90 degrees, and there is no power dissipation in the case of pure inductive circuit. Choke coil is a one which works on the principle of dash. Choke coil is a one which works on the principle of self-induction phenomenon. Is it clear or not? This is about the pure inductive type of circuit. Next we will be learning about the pure capacitive circuit. Okay.